With this, we will move on to the next item in the agenda, going back following in order to item number 7, habitat restoration needs for CHNEP expansion area. And we'll bring Justin Saarinen up to give us a presentation. Next slide, please. This presentation will cover the findings from the draft habitat restoration needs plan for freshwater Caloosahatchee River Basin, a landscape level approach to habitat protection, and the final draft of the habitat restoration needs phase 2 report to the policy committee for final approval. This supports all fish, wildlife, habitat protection, CCMP actions and activities. And with this, I will turn the presentation over to you, Justin.
Okay, thank you, Brian. Yeah, this is Justin Saarinen. I'm with Environmental Science Associates. I'm broadcasting from Sarasota, Florida, downtown here. I guess I'll read through some of the slides. The purpose of the HRN needs, the HRN plan, is to develop a plan for the entire partnership service area. This is an addendum to the HRN1, which was the habitat needs assessment for the partnership area, service area, before the addition of the service of the expansion. So the plan balances community needs, economic growth, water supply, aquifer recharge, water quality treatment, flood reduction, with natural systems and species needs to create positive impacts on the long-term sustainability of water quality, water quantity, natural systems, and species populations. What some of the outputs of this plan are going to be interactive maps of restoration targets on public lands and acquisition or easement opportunities for non-public land. These are, the way we modeled was using the best available GIS data and processes for the future habitat changes. And this includes the pressure from land use change associated with economic development and climate change. So implementing this plan, who can this information help? Who are we targeting? What can we run with? So we're looking at land use planners, we're looking at ecologists, we're looking at transportation planners, we're looking at water resource managers, environmental land managers, park and recreation managers, land acquisition programs, wildlife managers, and all the agencies that oversee a lot of that land management and water management activity. Okay, so I'll get started with my talk here. So this is the final report, and I think you all have seen this before. We're not going to get into too much background. We're mostly going to talk a little bit about the results, and we're going to get into some of the discussion items that have happened in the Technical Advisory Committee and the Management Committee and the Citizens Advisory Committee in the 2 times that they've had a chance to see it. Next slide, please. I think this map is pretty familiar to you all. You may not know that the expansion area is fully in the South Florida Water Management District. It's actually a pretty large, it's a large basin. It's second only to the Peace River Basin. It's 605,000 acres, which is pretty significant. And this magenta, this purple magenta area is the area that we're modeling. This is what we're adding on to the original HRN. Next slide, please. So the first task of this project was to look at habitat status and trends. And in this task, we used available South Florida Water Management District land use data sets. We looked at the status and trends of habitats from the years 1999 to 2016. Next slide, please. The second task is we researched, collected, and documented the existing, ongoing, and planned habitat conservation and land acquisition projects in the study area. Third task is we studied how the effects of climate change could likely impact the expansion area. And with this task, I'm going to go into a little bit of detail here because things have changed. We had some things that we needed to work through committee and make some revisions. And I'm going to talk a little bit about some of those revisions here in the next couple slides. So the average temperatures in Florida are increasing and are projected to continue to increase. The evaporation and plant consumption of water, also known as evapotranspiration, is directly related to the temperature. So meaning as temperature goes up, ET goes up. So with projected increases in temperature, there will be a projected increases in ET. The type of vegetated land cover distributed on the landscape is driven primarily by access to water. Plant communities are adapted and compete based on this. Thus, a change in water availability will lead to a change in land cover. What you're seeing in this slide here is you're seeing the cover of a document entitled Climate Change Impacts in the United States. This is based on all of the climate change projection models that a lot of information that we take from. The third point in this report is that there's going to be a decreased water availability. The graphics that you're seeing over to the right is to show how the landscape has evolved in Florida over time. And that evolution is primarily driven by access to fresh water. And part of that equation is also salinity. So freshwater being, a function of water that plants that are not been adapted to a salt environment can readily use. Next slide, please. So this is a model here where we are showing the duration of saturation, also known as hydroperiod, at 18 inches of depth. So we chose 18 inches of depth because that is found and known to be a critical depth for wetness, for plant, primarily for recruitment. This is where seedlings know to germinate. And it's the amount of time that 18 inches of depth is underwater that you can expect it can be wet. And the blue areas are wetter areas, the brown and orange areas are drier areas. The way that we came up with this model is we pulled data from all of the South Florida Water Management District wells through their DB Hydro database, developed cumulative distribution functions for each of these wells. So we know for each well, we know the depth and how long that depth water occurs at that depth. And then we krieg that. Krieging is just a fancy way of saying spatially mapped out so we know the areas where there are white dots, we know what those durations are. And so we needed to understand the areas that we didn't know, and that's where the krieging is. So that's where we come up with this model. It's interesting to see that it balances well with the Caloosahatchee River. So with this, we compared the land cover data that we developed in the first task. This is the 2016 land cover data that comes from SouthMud. And what we did here is we looked at each of these native land cover habitats and we identified a statistical profile for the minimum and the average depths to the duration of the 18 inches of depth hydro period. So how much do these habitats need and prefer the wet conditions? Next slide, please. So with the durations, so how do we understand the impacts of drying here? So with the duration of saturation surface and groundwater statistics for native habitats, those are those previous two slides that I showed you, we selected a single drying scenario of 7.5%. So the calculus that we came up with that is that we use the 7% drier from increased evapotranspiration. That's a published number that we feel pretty good about. There was also a lot of comments about the response to well production. What's going to happen if you're having a drier environment? Is there going to be more drying due to increased pressure on the aquifers? So we also added 2.5% drier due to an increase in the well production. And then the part that was a little bit more difficult and a lot more uncertain was precipitation. And if you look at these same forecasts, you'll see that precipitation is projected to increase and decrease by 10%. So it's a big hedge. So we went with 2% wetter due to increased precipitation events. And so that's where we came up with the 7.5% drier. That's where these numbers finally come down to. So once we've selected that scenario, we decreased that duration of saturation at 18 inches of depth by 7.5%. And then once we've done that, we were able to relate that back to native habitats to identify habitats that were going to be at high transition risk, where that duration of saturation was going to fall below their minimum threshold. The medium transition risk areas, these are areas that are a standard deviation of below the average duration, and low transition risk is everything above that. You'll see that there's a box in the slide that we were able to handle pretty well in the management committee meeting. And we weren't accounting for this model. We weren't accounting for recharge associated with the C43 reservoir. Obviously, that's a very big hydrologic feature in the future in this basin. Fortunately, Phil Flood and some other staff from SoftMud confirmed that there's a lot of design going into specifically addressing seepage associated with the reservoir, and to the best of their ability ensuring that there will not be groundwater leaking into or water from the reservoir leaking into the groundwater. Next slide, please. So with that, these are the results of this climate change. This is areas where you're seeing high transition risk in red, medium transition risk in yellow, and low transition risk in green. They definitely follow the patterns of where you have drier areas in the basin, as well as wetter areas in the basin. So these areas to the south and towards the east, using this data and this approach have the highest transition risk in the basin. And when I say transition risk, what that means is where you have hydric habitats, the transition to xeric or mesic habitats is something that you could take away from this analysis. Here's a little bit more of a quantitative look at those individual land cover habitats, what their current distribution is in the expansion area, and where they fall out in terms of their transition risk. Believe it or not, the high prairie is a transition risk, or the dry prairie is a transition risk. I'm not sure what is next on the list after dry prairie, but some of those hydro periods are going lower than what they currently exist in. But I think things to really look at are the upland mixed forest. That's a mesic habitat that could become more xeric. The wetland vegetated non-forest, that's a wetland hydric habitat that can become more mesic. Those are the areas that as managers you want to look out for and begin to think about as climate change begins to set in a little bit more. Okay, so this is the additive hybrid approach model. This is the fourth task of this is where we're actually doing the numeric and target setting here. This is where we're coming up with, in the next slide, you'll see that we're gonna come up with the blue and green maps. These are these proposed opportunities, proposed and potential opportunities, and also existing managed areas. So the green areas are the management enhancement targets. and you're going to see light green and dark green. The light green are where you have a non-native vegetation or habitat class that is in the public domain. It's managed by a public agency. The darker green areas, the light green areas are native, and the dark green areas are not native. So the dark green areas are non-native habitats where you can employ restoration activities, and the light green are areas that are already native. The blue series are opportunities. So this is where you have native and non-native proposed conservation or potential conservation. These are opportunity areas. The blue or native, these are areas that are high value habitat. The light blue areas are lower value habitat. They're non-native that are out in the private domain as well. The gray areas are areas that are not considered to have habitat value. The darker blue are these water features, surface water features, such as the reservoir and the river itself. Something that you'll notice is, and something that we've talked a lot about and discussed in the report, is the interaction of panther habitat with these proposed areas. And that's what you're gonna see with the teal here, the teal shading that you're going to see in here. This is actually a significant portion of the watershed. It's basically half the watershed area, and way more, probably 75% of the entire opportunity area. The reason why it is opportunity in most of the cases is because it's been designated as primary panther habitat by the U.S. Fish and Wildlife Service. There's a big push for guiding panthers to migrate across the Caloosahatchee River, and that's what's part of this plan. So part of the discussion here is the interaction between panther habitat and private land that has been identified as high habitat. And there's a lot of discussion. We've had a lot of discussion in the report, and a lot of suggestion for how those two things can coexist, and avenues and abilities to do that. So that I can point you towards that, and we've done a lot of discussion, a lot of thinking. So here we have these are the what's considered the strata. So this is where you have the upland areas and the freshwater wetland areas, and how the different additive hybrid targets and opportunities fall out within those two different strata. So we'll see here that that much of the upland is in native PC opportunities. There are also some restoration targets. You'll see that the freshwater wetland, most of that is native as well, although there are some freshwater wetlands that can be restored that are in the public domain as well. And there's basically no uplands or no wetlands that are in non-native PC opportunities. So all the non-native freshwater wetlands are currently in the public management sphere. And there's lots of opportunity for upland as non-natives. Next slide, please. And so this is the part with the discussion. And as I mentioned, there's been a lot of talk and a lot of thinking, careful thinking, and looking at all different sides of the issue in terms of the nexus between high quality privately owned agricultural land and active production that's within this expansion area. One thing that we found, we looked actually into a lot of agricultural literature, and we found that from a national standpoint, the ag land that's in the expansion area is high quality, very high quality. It's resilient. There's a lot of variety. There are a lot of resources to keep it going. And it's incredibly important, not only to the state of Florida, but also to the United States. That's just in terms of an ag resource, it's critical. The thing is that much of this priority, much of this land is priority Florida panther habitat. The idea is for migration to areas north of the Caloosahatchee River. And that's also critical to the survival of the Florida panther. What's well known and discussed is that panthers coexist with agriculture, but panthers do not coexist with non-rural development. So lands can be conserved, but not necessarily need to be targeted for restoration and still have habitat value. Conservation strategies must go beyond traditional land acquisition by government and include economic programs to preserve critical landscapes on private land. And we've done a lot of discussion on the report. This includes wildlife, BMPs, conservation easements, balancing habitat protection with other needs, including economic growth, flood protection, aquifer recharge, and water supply. And there's a lot more detail in the report. I encourage you all to reference it. And with that, I think, what are some of the next steps? So what you'll be seeing is you're going to be having pretty good access, very, very quick access to the results of the study. Looking at the maps, being able to look in your particular area to see what the HRN is saying about your particular area. There's already an existing viewer up right now, but we haven't had a chance to bring the expansion area into that viewer. So really, it's making the results of the study very accessible, primarily through a web mapping interface. And that's something that the partnership has plans to do here in the near future. Thank you very much.
All right, thank you very much for that presentation. Are there any, maybe time for one question? Okay, hearing nothing, we will move to the action. We need to, is there a motion for moving this forward for the approval of the final draft habitat restoration needs phase 2 report?
So moved. Eigelhart.
Second.
Thank you, John. We have a second. Any discussion? All right. All those in favor, say yes.
Yes.
Yep.